Okay, trig ratios. We know 3. We're going to learn 3 more today. Okay? So the first 3 are pretty simple. 6 trigonometric ratios. Your life just expanded. You need to know them. So sine's pretty easy. So sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. So those shouldn't be shocking or alarming to anybody. All right, so here we go. Cosecant is the reciprocal trig function of sine. So cosecant theta is equal to the reciprocal of sine theta, which also could be written as, what is this as a reciprocal?
Hypotenuse over opposite.
Exactly. Well, isn't that crazy? Anybody want to guess what secant is? Yep. So secant is 1 over cos theta, which also can be written as hypotenuse over adjacent. You're just doing the reciprocal. Pretty easy. Okay, I just want to point out that sine reciprocal starts with the letter C. And cosine that starts with the letter C, its reciprocal starts with the letter S. I only say this because people screw that up. They think that the reciprocal of sine is secant, but it's not. It's cosecant. So you just got to remember opposite letters match. I point that out only because it is something that people get confused really easily. So S goes with C, and C goes with S. All right. So you guys remember that tan could also be written as sine theta over cos theta. You guys remember that? We just did that in a different question, right? Sine. Okay, so when we do cotan theta, that's the reciprocal of tangent, which could be written as adjacent over opposite, or it could be written as cos theta over sine theta. So, not terribly anything like earth-shattering new. They're just opposite, like they're just reciprocal functions to the ones you already knew. Okay, so reciprocal functions, you're responsible for knowing them. You're responsible for knowing that the reciprocal to tangent is cotangent. This is all going to be really, really important when we start doing chapter 6 and we start doing identities. So we start replacing things. You know how you guys get common denominators in fractions? So you change a fraction to look like the other fraction? That's what we're going to be doing in identities. Except they're not fractions, it's all trig stuff. Okay, it's all super fun. All right, so this is a big thing. If I say exact values, anytime I have that word, exact, there's no decimals. We're not using decimals. We're leaving things as radicals. We're leaving them as fractions. This is where you're going to spend time with your no calculator. Okay? So the reason why is we want the exact value. We don't want an edited version. Like if I throw my calculator under here and I go 1 divided by 3, that 3 repeating on the calculator, that's an edited version. Because if I go 2 divided by 3, My last digit you see rounded to 7, but that's not true. It's 6 repeating forever and ever and ever. So my calculator is doing some rounding for me. 2/3 is the exact value. 0.6 repeating is an estimated value. Okay? So we're gonna be really good. Okay, so let's see if we can do this without our unit circle. Okay, if you need your unit circle, we'll get there, don't worry. This is just we're trying it without the training wheels right now. A cos of pi over 3. Does it help you if you know it in degrees? What's pi over 3 in degrees? 60. Does that help you at all? I feel like, no, not really, maybe. Okay, all right. So I know, this is how I'm thinking about it in my head. I know that I'm here. So I know I'm in quadrant 1 because it's pi over 3. I know that this is going to be a short, long. So this is going to be 1/2 and root 3 over 2. Because like I said, I told you guys that the short longs make sense to me. My x is going to be short, my y is going to be tall. So I know that. So does cosine represent the x value or the y value? X, yep. This is the x value in a coordinate pair. So what's cos of pi over 3? It's right there. The answer is right on the page. 1/2. So there's not really any, like, it's not hard math to do, but trying to remember it all or math it out is difficult. That's the difficult part. Okay, secant. What is secant the reciprocal function of?
Cosine.
Cosine. So what I do in my head is I figure out what cos of pi over 4 is.
Pi over 4 is 25.
Is 45. So that's right in the middle.
That'd be square root of 2 over 2.
Right. This is the nice one. This is the one that they're the exact same. Anything with a denominator of 4 is going to be root 2 over 2, root 2 over 2.
They're going to be off.
So then cos of that is equal to root 2 over 2. So what is the reciprocal of that?
2 over root 2.
2 over root 2. That makes sense to everybody? Like how I'm just mathing it out. There's no like calculations that I'm doing. Okay, cosecant is the reciprocal function of what? Sine. So I'm going to solve for sine of 2 pi over 3. Okay, you know what I know? I know that pi over 3 is in quadrant 1. So I know that 2 pi over 3 is going to be in quadrant 2. I know they both have denominators of 3. So their coordinate pair will be the exact same, just this time the coordinate pair is in quadrant 2. So we got a short long happening here. So this is going to be a negative 1/2 and a positive root 3 over 2. Sine is y, so that's going to be the root 3 over 2 and it's positive. So what's cosecant of it?
2 over root 3.
Mm-hmm. And you guys are like, this isn't fair, I don't know my unit circle yet. And you're 100% right. Your unit circle is like, it's your training wheels. But if you can find ways to math it out, then you're going to be okay. Okay, do you guys feel good about that? Sort of, kind of, maybe? Nobody's crying yet, so this is good. Cotan. So tangent
That would be
of 5 pi over 6. This is where Claudia's data table comes in handy. But if you don't know that,
5 pi over 6 quadrant 2.
quadrant 2, yeah.
It would be
It's down here this time. So it's a long short.
Negative root 3 over 2 and 1 times.
Because if a pi over 3 is a short long, then a pi over 6 is going to be a long short. You guys are like, crazy lady, I don't understand your long shorts. And that's okay. These things happen. Okay, so now what I know is I know that this is going to be sine divided by cosine. Ooh, that's supposed to be a 3. But I'm not looking for tan of 5 pi over 6. What am I looking for?
Cotan,
Cotan.
which would be negative root 3 over 1, just negative root 3.
Negative root 3. Okay, so I do have to warn you that, again, like we talked about the details of things. If you're going to do this, if you're going to figure out what it is as the original function, you need to label it. Because if you put this 1/2 divided by root 3 over 2, and you didn't tell me that it was for tangent, that's actually incorrect for cosine, or cotan, sorry. Does that make sense to everybody? Like you need to label it and tell me that you're doing the reciprocal function, and then you're getting to here. Like that tells me the story. If you put this down, I don't know if you think this is cotan, or if you think that's cotan. Does that make sense? Like you're not telling me your roadmap to it. Jordan, are you okay over there? There's a lot of squinting. Is the light on it?
No, it's fine.
Okay. I worry, okay? I worry. All right, so this is a double doozy on this one. This one is a double doozy. Double doozy. It's a negative angle, and it's a cotan. Double. It is a double doozy. So what I want you guys to do is figure out what the positive coterminal angle to this one is before you go anywhere with that. I'm just curious on Wednesday.
To bring the test in my class?
Yes, yes. Just as long as you don't have an E to B scheduled and the rest is scheduled. Everybody figure it out? No. I thought Krentz would have had a longer question for me.
7 pi over 4, wait, no.
What do I add to this to get a coterminal angle?
360.
360, but I'm not in degrees. 360 is the correct answer.
2 pi.
You add a full rotation. Makes sense, right? Like if you're at 30 degrees, to end up at 30 degrees again, you need to add a full go around the circle. So 2 pi, which is really, I need a denominator of 4, so that's going to be 8 pi over 4. So what's the coterminal angle?
7 pi over, no, 5 pi over 4.
Does that help you? Where are you at 5 pi over 4? Are you greater than 1 or less than 1? Just look at that fraction. Is that greater than 1 or less than 1?
Greater.
Greater. So I know I'm definitely past 1 and 2, so I've got to be in 3 and 4. Well, I've got to be either in 3 or 4. And we know that this one down here is 3 pi over 2.
That doesn't go.
So that is 6 pi over 4. So where are you?
You're in quadrant 3. both
You're in quadrant 3.
negative.
Both are negative. And it has a denominator of 4. So this is the really easy one. What are my coordinates here?
Negative root 2 over 2 and negative root 2 over 2.
And I'm going to get you to do this right in your head. What is something divided by itself?
1.
So what's cotan?
1, negative 1.
Positive 1, because they're both negatives, right? Oh, I did no math on that and I just threw down the number 1. So I hope that my verbal explanation was good because I'm not showing you mathematically what I just did. Maybe I will just for funsies. So cotan at pi over 4, so if I do cotan at 5 pi over 4. Really, that's going to be equal to cosine of 5 pi over 4 over sine of 5 pi over 4. And we know that cosine is negative root 2 over 2 divided by negative root 2 over 2. So negative root 2 over 2 multiplied by 2 over negative root 2. That's going to give me 1. That was an awful lot of math when you know already. So this is about being efficient. But if you need to write this out because we're just learning this now, that's okay. That's what it would look like. We get the exact same answer. This is the minimum amount of work. Actually, that's the minimum amount of work. Some people can see this in their head that negative 3/4 pi is right here. You are the most amazing people in the world because I still struggle with that, the visual. I like to make it into a positive coterminal angle because I'm more comfortable with positive angles. But it's what you prefer. So the minimum amount of work is the number 1. That's what you can show me and get full marks for that. The danger with that is if that, like this would never be a huge mark question, but if you put down something else, if you put root 2 over 2 or something like that, you're going to just get it wrong, right? If you don't show me any work. All right, cosine of 29 pi over 6. So what am I going to do here?
Try to do full rotations to try and find the right.
Okay, so Cam is already on it. He's saying that I want to find where I am on the unit circle in one rotation. Because I know that this has many in it. So I know that 2 pi is equal to 12 pi over, sorry, there should be an equal sign there, 12 pi over 6. That's a full rotation.
So it needs 2 rotations.
So you're going to take 2 full rotations out of it, which is 24 pi over 6. So a coterminal angle is 5 pi over 6. So this is where this is how we use those coterminal angles to help us better understand stuff. I'm going to pop over here for a second. Denominator of 6, denominator of 6. So, oh look, the exact same point, right? It doesn't matter where they are. If it has a denominator of 6, your coordinate pairs, the numbers will be in that right order. It's a long x and a short y. So it's going to be this point. These just happen to be the exact same angle.
Yeah.
So what's cosine of this?
That would be your x value, which would be negative root 3 over 2.
So I didn't do any math. I just know that cosine is my x coordinate. So all I had to know was that coordinate pair, and I solved it. Okay. Moving on. Okay, so this is a double doozy again. It's negative and it's multiple rotations. So what do you guys want to do? Do you want...
I just added 4 full rotations.
4 full rotations is what you did?
Because that would be 48, since it's still over 6, it'd be 12.
Right.
Over 6 with 2 pi. So then it'd be 48 full rotations to get it just in the positive.
Okay. So what Cam's doing here, for those of you at home who can't hear his rationale, is he said I did 4 full rotations. So I added 4 of the full rotations. So cosecant of negative 47 pi over 6 plus the 48 pi over 6. And that's going to be, so the positive coterminal angle is pi over 6. Now what did I say about pi over 6? No matter where we are, like pi over 6 is going to be right here. So it's going to be a long and it's going to be a short. So the coordinate pair will stay in this order, the signs will change so that they're positive. Cosecant is reciprocal to
Sine.
sine, okay? So that's 1 over sine theta. We know the sine of this one, so I'm just going to slide back up. The sine of this one is 1/2.
Would be 2.
So the reciprocal is 2. I guess maybe I shouldn't. That's 2. I got a lot of errors happening there.
This does not look nice.
It's super easy. It's super easy. What we just did, this is going to be a question on your quiz. Number 8 is going to be a question on your quiz. Hint, hint, nudge, nudge. Question on your quiz. We're going to go ahead and we're multiplying all these things, right? Multiply, multiply. Yep. That's okay, you're going to get some time because I think we're almost done this lesson. No, we're not almost done this lesson. I love you guys. Okay. All right, so you're going to treat them as 3 separate things, okay? If this helps, do this. Cos of 30 pi. Figure that out. What's cos of 30 pi?
It'll be the same as 2 pi, so it'll be 0, 1. No, 1, 0. No, 0, 1. Wait. No, 0, 0.
Nope. There's no point that's 0, 0. I love it. Where are you guys at 30 pi, you crazy kids?
Wait.
What do I got to take? What do I got to take out?
30.
No, what are your full rotations in?
2 pi.
2 pi's. So how many 2 pi's am I taking out?
15.
15. So we're going to minus 2 times 15 times 2 pi. And we're going to have 30 pi minus 30 pi. What the heck? So cos of 0. So where are you?
0.
No. Yeah, you're at 0 degrees, 0 radians. Where are you?
The middle.
Nope. You're right there.
And that one.
Right? What's that coordinate?
0.
Nope.
1, 0.
1, 0. These are the hardest ones because it's like, okay, I've memorized everything else, and then there's these axes, and it's like, what is that? So we're dealing with cos. So cos of 0 is? Cos is the x or y? Cos is the x.
So 1.
Okay, so now let's do our next one. Secant
2 pi over 3.
2 pi over 3. Secant is the reciprocal function of cos.
2 pi over 3. Quadrant 2.
Okay, I'm just going to slide this down for a second. Let's look at what we just did. If this is pi over 6 and it's a long short,
Then the other one would be short long.
short long.
So it would be 1/2 over.
So remember, it'd be negative 1/2 and positive root 3 over 2. Because you're in quadrant 2 here for 2 pi over 3. Remember that in quadrant 1, it's pi over 6, pi over 3, pi over 4. Like there's no numbers with it. So I know it can't be quadrant 1. I know 2/3 is less than 1, so it has to be in quadrant 2.
So it would be negative 2 for that one.
Okay, last one. So we got cosecant is negative pi over 3.
1 full rotation just brings you to pi over 3.
Nope, 1 full rotation brings me to
You're going to go down. I'm trying to copy 7 still.
Oh, negative pi over 3 is just, yeah, that's why I'm making a mistake. 5 pi over 3.
right. So Cam just rationalized it out. Really, mathematically, what I did was I took negative pi over 3. I added 2 pi. I need a common denominator, so that's negative pi over 3 plus 6 pi over 3. because this and this are the exact same thing. They just have common denominators. And if I add these two things together, I'm there. What quadrant am I in at this point?
4.
Right? Think about it.
Positive vector.
You start here, you go a negative third, you're right there. And you're really, really close to 2 full rotations. So if I went this way, that's 5 pi. That's a negative pi over 3. And this way, it's a 5 pi over 3 that way. So you still end up in the same place. It just depends on where you're going. Okay, cosecant is the reciprocal function of sine.
This is your y.
Okay, good. That's good. That's a very key point. We know we have a denominator of 3. We had a denominator of 3 here. I know that in this quadrant, it's going to be it's going to be a positive root 3 over 2 and a negative 1/2 because I'm in quadrant, this is in quadrant 4. So my y is negative, my x is positive. So do you see how like your whole grade 11, grade 9 is all coming together to solve this? That's going to give me, so cosecant, chi you said was the reciprocal of sine. Sine is negative 1/2, so what's the reciprocal of that?
Negative 2.
Negative 2, so we're going to fill this in. So we have 1
Times negative 2.
times negative 2 times negative 2.
4.
The answer is 4. This question will be on your quiz tomorrow.
That was the most complicated way to get the answer 4.
Yep. Oh no, I'm sure there's more we could do to make it more terrible.
Hold up, I forgot to copy that.
Sorry, okay, I apologize.
I only finished the
Nani?
first round.
Yep.
Like 5 pi over 3 can't be, like the coordinate is I think wrong.
The coordinate's wrong?
No?
Okay, let's go back to my unit circle. Maybe I made a mistake, that's very possible. You are right, my coordinate is wrong. My coordinate is wrong for 5 pi over 3. What? Okay. Oh. We were 6 up here. No, my coordinate. This coordinate's incorrect. But this coordinate was correct, and then I switched it for this one. Did you guys see that? This one's correct. It's got a denominator of 3, and I did it correctly. And then I switched it here. Thanks for catching that, Het. So this is going to be, we'll just scratch that out. So this is positive 1/2 and a negative root 3 over 2. And then reciprocal it. So it's going to be 2 over negative root 3. So this is going to be 2 over negative root 3. And so my answer is going to be a positive 4 over root 3. Is that better, Het?
Hold on.
Yeah.
Okay, thank you. I had it right in one place and then I screwed it up somewhere else. How does that happen?
Keep it up, that's a little bit. Thank you.
Okay.
I've been taking the time to really understand this, but this point I'm like just copying it.
Frantically copying it, review the video later.
Yeah, I'm like trying to figure out what went where, and I'm like, oh, what order did this come? So I at least know where I am. Okay, what is the cosecant negative pi over 3 start?
Okay, what are you talking about?
The third term.
This one?
Yeah, where does it start?
This whole thing is it.
Oh,
So that goes to there. because we don't want that negative angle, so we went to there, and then we got the answer to go to here.
Sorry.
That's okay.
I can't copy when people are talking about things I need to listen to because I can't do both at the same time.
Look at me, I'm switching coordinates, like I'm trying to talk and write at the same time, and it's a good thing you guys are here taking care of me, because together we're gonna get through this. Okay, can I flip the page yet, Kai?
No,
No, okay.
almost done.
That's okay. And I go quick, and that's not fair to you guys.
Well, I mean, I haven't even gone to like try and figure out what 4.3 has going on. So, I'm fine with lots, but
Awesome, perfect. Okay, can I flip this?
no.
Still no, okay.
Almost done.
Then you're not allowed to talk until you've got it covered. Guys, this year's Pi Day is on a Sunday.
Sad.
It is sad.
Now we don't get any pie.
I don't know if we'd be allowed to do it under COVID restrictions anyway.
They don't have to know.
True story, true story. We can all just,
And then you are they. You want, you're the.
it's true, yeah. Oh, color do I want? I'm gonna try teal. You guys can tell me if it's a good idea or a bad idea. I think it's gonna be a bad idea. Kai, am I good to flip?
Yes.
Yay!
Sorry, for the first like 6 minutes, I tried to get my hands to right adjacent, and I could not spell it right. Just it.
You know what? We let that go. We let that go. All right. Okay, approximate values. So now this is going to be with our calculator. How do we feel about the teal? Is it okay? Yes, no? You want me to go to a different color?
That's good.
Okay. All right. So the reason why I know I have to use approximate values on this is because this is not on the unit circle. Nowhere do we have denominators of 5. It's still a valid value, but it's not one that I'm asking you to memorize. So it is on the unit circle. What quadrant would this be in?
3. No.
2.
Definitely not 2, because 7/5 is bigger than 1, right? You guys would agree with me? Let's just figure it out. What's 7? 7 divided by 5. 1.4.
I have the unit circle rotated that way in my head.
Okay, so we know that this is 1/2 of a pi. We know that that's 1 pi. We know that's 1.5 pi, and we know that that's 2 pi. You guys would agree with me? So now if I ask you this, if you know 7 over 5 is 1.4, what quadrant are you in?
3.
You're solidly in 3, right? So this is how I kind of figure out what I'm doing, where I am, how does it look. So I know that this is in quad 3. What do I know about quad 3? What do I know about tangent in quad 3? Let's be specific.
Positive.
It's positive. So tan. Okay. Oh, I don't have to really math this out. My calculator's going to do it for me. All right, here we go. You need to change. Look at this. Exciting stuff. You need to change. Oh, I got to go to mode. Your calculator for the very first time into radians. So you need to be not in degrees anymore. You need to be in radians. So if you have your handy dandy calculator, my scientific one I loaned out today. Here's a Staples one on Mr. Caldwell's desk, so I'll grab that. Okay, so if you look at this, see how it has DEG at the top of the screen? Or the letter D or DEG? That means your calculator's in degrees. So on this calculator, I'm going to find this button, DRG, degrees, radians, gradients. So if I hit that button, it's going to move over one to rad. If I hit it again, it will move over to gradians, which we don't use. And then it goes back to degrees. So I want to be in radians. All right, we good? So you guys can't have graphing calculators, but I always do everything in a graphing calculator. So in my graphing calculator, I'm going to go tan of 5 pi divided by 7, and I'm going to close my brackets.
7 pi over 5.
Tan of 7 pi divided by 5, and I'm going to close my brackets. And I'm going to hit enter. Now I anticipate tan to be positive, right? We all said it should be positive, and I get a positive number.
3.3777.
Okay, now if I do it in my scientific calculator, this is going to be the challenge. Okay, so, so 7 times, where's my pi button? Pi equals, divide by 5 equals, and then I'm going to go tan. Okay, I get the same answer. I get the same answer for both. So, and it says we're going to round to 4 decimal places. That, ladies and gentlemen, is the standard rounding. Because that 8's going to round the 6 to a 7. I really like no calculator, because I know with a calculator I have infinite answers that I can screw up on. I have a hard enough time when I've given myself a limited number of answers. Okay, cos of 260. Where is 260, ladies and gentlemen? What quadrant is 260 in? Try again. 3, right? Because 270 is right here, and we're a little bit less, so we're in quadrant 3. So what do we know about cosine in quadrant 3? It's negative. So we anticipate our calculator should give us a negative answer. Okay, notice this one's in degrees. So I have to switch my calculator back to degrees. So now I'm going to put in 260, and I'm doing cosine. So negative 0.1736. All right. I don't know how our calculator will handle negative degrees. Let's try it. So, okay, calculators are limited here. Calculators are limited. Do you see that? I put a really black dark thing there. It starts to white out kind of the background. I take it away, and my background goes back to normal. It's auto-adjusting, which is kind of a pain in the butt. What is cosecant the reciprocal function of? Sine. So notice that our calculator doesn't have any like cosecant, cotan. It has none of that. So you have to be smarter than your calculator. Okay, so let's just try negative 70, negative sine. Oh, it did it.
Cosecant with like cos with like a negative on the top.
That gives you not your reciprocal, that gives you the inverse. That will find you the angle. We have the angle, so you can't do that one. Okay. Where would you anticipate negative 70 to be? What quadrant would you? That would be in quadrant 4.
It's positive.
And what would we anticipate sine in quadrant 4 being? Sine should be negative, right? So I get an answer that's negative, which is pretty cool. But sine, so sine of negative 70 degrees gives me an answer of negative 0.93969262. You're like, Scallion, you said 4 decimal places. That's not my final answer. How do I do the reciprocal of that? So cosecant of negative 70 degrees is going to be 1 over negative 0.939696262. So you got to do that in your calculator. So 1 divide by negative 0.939696262. Negative. And that's going to give me negative 1.0642. So here's the deal, ladies and gentlemen, I hope that you guys remember it, is that you do not round until your final answer. You must use all decimal places until your final answer. If you round early, you're going to get a wrong answer, or a truncated answer, or a rounding error. Just for funsies, what is the positive coterminal angle to this?
290.
Yep. So if I did sine of 290 degrees, because that's the positive coterminal angle, notice I get the exact same answer. So whether you did the negative in your calculator or whether you did the positive coterminal angle, it doesn't matter when you have, because you're at the exact same place, so you should get the exact same number. So doesn't matter which one you use. Okay, I'm going to leave you guys to do this one on your own. So try this one on your own. I'm going to do it, you're going to do it. Hopefully I don't screw up. Make sure your calculator is in degrees. Mine is not. Say it to you guys and then I don't do it. Okay, I'm going to drop my answer on here. You guys can tell me if you got similar, same, did I do something wrong? I found that I wanted to go to a positive coterminal angle because right off the top of my head I couldn't see where negative 500 degrees was. I couldn't see that in my head, so I made it a positive coterminal angle because I feel pretty comfortable I know where 220 is. So 220 is in quadrant 3, I know that cosine will be negative. Did you guys do that or did you do it off the negative? You guys put in your calculator as a negative and we're like, crazy lady, why are you making us do this stuff? And that's perfectly fine. I showed you you're going to get the same answer no matter if you use the positive or the negative. I used the positive. Did you guys get this for an answer?
Yeah.
Yeah? Okay, so you're pretty confident in this. Calculator is awesome.
And now we're back to
Okay.
restrictions. That's the word.
What?
Restrictions are back.
Restrictions are back. This one's a nice restriction though, everybody.
Just one rotation.
One rotation, right? This is one full rotation. Start at 0, end at 2 pi. Now, what this does tell us though is that all answers are given in radians. Nowhere here does it say you need to use radians. Nowhere here does it say you have to solve for this, but your restriction tells you, your restriction's guiding you, that your answers have to be in radians. Okay, so now we're going to use our unit circle for sum. So this one I can use my unit circle. This one I can't. So that's going to be a calculator. All right, so the first thing I'm going to do, where is cosine positive?
Quadrant 1, quadrant 4. Yeah.
Quadrant 1 and quadrant 4. So we're going to have two answers in this because it's given us a restriction. We know our answers are going to be in quadrant 1 and quadrant 4. This is a really good example of scallion versus other way of doing it. If I rationalize that denominator, so we'd be doing cos theta of root 2 over 2.
So it would be 45, which is pi over 4.
Okay, so right away, I know that anything that's root 2 over 2 is going to be pi over 4. Like it's going to have a denominator of 4. In quadrant 1, the answer actually is pi over 4. Do you guys remember your rules from grade 11? No. So this one is 360 minus theta reference. Theta reference is theta. 180 minus theta reference is theta. Sorry, these are all equal to theta. And this one's going to be theta is 180 plus theta reference. Now that's how we did it in grade 11 when we didn't know about radians. So if we're in quadrant 4, what do we replace that 360 with? 2 pi. 2 pi minus pi over 4. So answer 1, answer 2. And I put 1 and 4, like theta 1, theta in quadrant 4. You don't need to do that. That just reminds me what quadrants I'm in. Some of you will memorize the unit circle, and that's okay. I have to math it out because I'm not a memorizer. Okay, moving on to the next one. I thought this was going to be a really short lesson, but wasn't. So sine is negative. Where is sine negative?
Quadrant 3 and quadrant 4.
Okay, so if you guys remember from, this is a grade 11 question, but now we're going to be in radians, so our calculator has to be in radians. So this becomes theta reference because we drop the negative sign. We drop that negative sign. All right, so I need to go into my mode. I need to change into radians because we're in radians now. All right, so when we are solving for theta, that's when we do the second function sign button in our calculator. And I'm just going to write that down in our notes so that we have full and complete notes. So 0.879, close my bracket. And theta reference is 1.0737600909. You're like, scallion, 4 decimal places. Theta reference isn't my answer. Theta reference isn't my answer. So now we need to do the rules for quadrant 3 and quadrant 4.
Add 180 and subtract 4.
Okay, but we're in radians.
Add pi and subtract 2 pi.
So I'm going to go add pi. So in quadrant 3, my answer is going to be 4.2154. No units of measure because I'm in radians. Oh, it's so tempting to put that degree symbol there. And now we're going to do quadrant 4. So that's 2 pi minus 1.0736. 760909. So 2 pi minus So this is a lot of grade 11 work, and the only thing really new to this is that we're dealing in radians, or we're dealing in exact values. Okay, does this excite you? It should.
Yeah.
No.
What do you mean?
The reason why it excites me is because it's on the unit circle,
Yeah.
right? 1/3 pi for tan is on the unit circle. And if we flip back to the Claudius data table, we know that anything with a denominator of 6 is going to be 1/√3. Because you're like, I have no idea, lady. How am I supposed to pick that out? Fair. Totally fair. So the negative tells us we are in quadrants. Okay, quadrant 2. That's supposed to be a Q. Quadrant 2 and quadrant 4. Right? Our cast rule tells us that. So where is the first time that we see, so tan theta r of 1/√3? I'll help you out. It's pi/6. So where are we in quadrant 2? So the rule in quadrant 2 is pi minus pi/6. So we're at 5 pi/6. And the rule for quadrant 4 is 2 pi. Guys, sorry, this is no, pi/6, we're good. Pi/6. So this one's going to be 11 pi/6. So those are my two answers.
Hey, how do you get pi/6?
Who, what?
1/√3 pi. So theta r is 1/.
So anything that's 30 degrees is going to be 1/√3.
Okay, so how did you get the pi? Oh, right.
So that's my, oh, geez Louise. Geez Louise, guys.